Okay, good morning, everyone. You ready to get started here?
Good morning.
Okay, so we have I'll put up what we're going to do today, but I wanted to just point out something before we start, that back on February 28th, we covered something called quadratic inequalities. And so, excuse me. If you look back in your notes, you'll see how we went about solving quadratic inequalities, and that it was different than solving a quadratic equation. I showed you kind of a side-by-side comparison. And what we had to do to solve a quadratic inequality is we had to first solve the equation, and then we set up we broke up the number line into some regions and then tested some points, just trying to get you to kind of remember something we've done, because we're going to be doing something similar to that today. And I don't want it to seem as if it's coming out of the blue. Like, we did kind of talk about this at some point. So if you're a little lost on it, you can go back and reference February 28th. All right. So here's our plan for today. We're going to talk about polynomial and rational inequalities. On Monday is our test. I gave you a review to look at last class, right? And I have that review here. I asked you to try and do a couple of these problems. I do have the solutions to that, which I will provide you as well. I'll provide you the solutions to that review. And then on this review, it says on number 7, you got to solve some inequalities. And so that's what we're doing today. So your homework for tonight, okay, the homework that you're going to do for 5.5, I'm not going to assign you homework. It's going to be out of the online homework system. So where you've been doing some of your homework before, same place, just go back and there's an assignment. In fact, the problems I'm going to do today as examples, I just pulled directly from your homework. So it'll look very similar to what I do here in class. Are there any questions on that? I've had a few students emailing me, hey, am I supposed to do the online homework? And so I'm trying to let everyone know in the beginning of class or at the end of class, like what to do for homework. So I hope I'm being clear on this. We're okay? No questions? Okay. All right. Man, I was doing fine. I start talking now. All right. So polynomial and rational inequalities. Let's get started. So we are going to first look at our first inequality. And here it is. We have x minus 6 squared times x plus 9 greater than 0. So what we're trying to do here is we're trying to figure out what values of x I can plug in that would maintain this as being true, that the left side of this would be bigger than 0. Now, you might look at that and kind of recall that when we were talking about polynomial functions, which is going to be on this test, right? You have to be able to graph a polynomial function on this test. Well, if we were to take the left side of that equation, or sorry, inequality, just the left side, that right there is a polynomial function. Now, it's already been factored for us, which is great. If we were asked to sketch this, there's a whole set of steps, right, to sketch this. And one of the steps that we would have would be to find the x-intercepts, right? And to find the x-intercepts, what we would do is we would take that function and set it equal to 0. So we would set x minus 6 squared times x plus 9, and we would set it equal to 0. And then we would try and figure out, what x's make this true. We are kind of looking at the same sort of problem here on the left, except that we want to know when this thing is bigger than 0, right? Not equal to 0, but bigger than 0. So I guess what I'm trying to get at here is that what we're about to do is nothing new in terms of, we've done sort of the solving of this equation before. We just haven't looked at it as an inequality. So that's what we're doing. So how do we go about this? Well, first step is we're going to take this and we're going to turn it into, so you're going to solve it as an equation. All right, not an inequality, as an equation. This is exactly what we did back in February when we were doing quadratic inequalities. We first set it equal to 0, figured that out, drew a number line, and then, you know, figured out what's going on. So we're going to do the same thing. We're going to set this thing equal to 0. Remember, we want to know when it's greater than 0, but we're going to first figure out when it's equal to 0. And since the left side of this equation is already factored, all I have to do is set each factor equal to 0. And I get two solutions, 6 and -9, right? 6 and -9. So what I can do now is I can, on a number line, I know that this equation is equal to 0, or this is going to be true when x is -9 or 6. Okay, so -9 or 6, and that breaks our number line into 3 regions. And now what we can do is we can test some points to see whether or not we get this to the inequality to be true. So I'm going to pick some points. Let me pick let's say -10. I'll pick a number in here like 0, and a number over here, maybe I'll pick 8. And what we're going to do is we're going to test those in the original inequality and see if it's true or not. Okay, so let me first plug in -10. If I plug in -10 minus 6 squared, and then I do -10 plus 9, the question is that bigger than 0? Right? Is it bigger than 0? So when I take this together, I do -10 minus 6, I get -16, but I'm going to square it, right? I'm going to square it. So it's going to become positive. This is a positive number. I don't care what the number is. Times, and now I do -10 plus 9, that's -1, that's a negative number. And when I take a positive and I multiply times a negative, I should get negative, shouldn't I? And so a negative number, is a negative number bigger than 0? Okay. Negative number, think about where 0 is on the number line, right? Oh, that's my number line, right? A negative number is over here somewhere, right? That's less than 0. This is not true, okay? This is not true, which means that anything to the left of -9 will not work. Now, I'm wondering if anyone's going to really be able to impress me here by telling me whether or not we can figure out the remaining 2 regions without doing any more work. Like, in other words, just looking at this, I can tell you right now whether or not those regions will work. Can anyone figure out how we might be able to do that? What I know is that to the left of -9, I get a negative number, so it's not true, right? It's not bigger than 0. When I plug in 0, am I going to get a positive or a negative?
It's going to pass through -9, right? So it'll end up being positive afterwards, right?
Okay, good, Diego. It's going to pass through -9, right? But Diego, is it going to bounce off -9? What if it bounces off -9?
It wouldn't, because -9 it has a multiplicity of 1, right?
Ah, okay, good. So remember multiplicity? Remember that when you're solving for the x-intercepts over here, we talk about this multiplicity and we go back to these powers, and these powers tell us whether or not we bounce or cross, right? So what we're really doing here, and this is the big picture of this, is what we know right now is that if we were graphing this function, right, over here, if we were graphing this, at -9, we have an x-intercept, and at 6, we have an x-intercept. I just tested that at -10, the graph would be negative, which means my graph would be down here somewhere, okay? When I get to -9, I must pass through -9 because the multiplicity on that factor is a 1, which is odd. Odd means cross. So my graph has to come up here, look like this, right? And then when I get back to 6, what's going to happen? Am I going to cross through 6 or bounce off 6?
Cross.
What's the multiplicity on the factor that gave you the 6?
Bounce, I'm sorry.
Bounce, right? It's a 2, so it's going to bounce. So I know that my graph actually looks like this. Y'all see that? So when we're asking this inequality right here, when is this thing bigger than 0? We're really asking when is the graph above the x-axis, which happens in here, right? That corresponds to this, bigger than 0, above the x-axis. So I know that everything between -9 and 6 will work, but and also anything after 6. Sorry, I should have highlighted that. This over here as well. Do you follow that? It's a little bit tricky. Now you could, if you wanted to, just plug 0 in, see if it works. Plug in 8, see if it works. But if you understand the multiplicity idea, then all you have to do is really just check one of them and you should be in business. Now I need a final answer. Okay, I need a final answer. My final answer should be some interval. So do we all agree that between -9 and 6, our graph is above the x-axis, right? Above. What about at -9? At -9, isn't my graph touching the x-axis? So it is equal to 0, right? Am I solving equal to 0 on this inequality? No, right? It has to be strictly greater than 0. So I do not want to include -9. Do I want to include 6? No, because at 6, we're equal to 0 and I want to be bigger than 0. So the only x values, this is my final answer, okay, the solution here to this is that all my x's have to be between -9 and 6, okay? Parentheses on both ends of those. This is an interval, okay? We're talking about an interval, not a point. Union, and then I want everything past 6. So 6 to infinity. This would be it. Questions? The hell? You sure? We're gonna do another one. Let's see how the next one goes, okay? Big idea is that this is very much connected to graphing polynomial functions, okay, something we've already done. And the more we understand about this, the easier this is going to be for us to do. All right, let's try this one. Okay, the left side of this, right? The left side of this looks like a polynomial, doesn't it? X cubed minus 3x squared greater than 0. We have a polynomial inequality. Okay, this is called a polynomial inequality. So is the previous one, polynomial inequality. All right, well, in the last one, it was already factored, wasn't it? So this one's not. So first thing I'm going to do, I'm going to set it equal to 0. I'm going to try and figure out where this thing is 0 first. And so I've got to do some factoring. Well, good thing is it's an easy factoring. It's just a GCF. I can pull out an x squared. And then I can, from here, I can set that equal to 0. I get x is 0. And then on this one, I set that equal to 0 and I get x is 3, right? So watch how I'm going to do this, okay? Pay attention. I'm going to just think about what the graph of this looks like. I know that the graph at 0, I have an x-intercept, and at 3, I have an x-intercept, right? That's if I was looking at this as a function, as a polynomial function. This graph, right, would look like this. Now, there's something else I know. I can use the leading coefficient test. Okay, leading coefficient test, where I look at the degree in the leading coefficient, which is a 1. And that would tell me that the left side goes down and the right side goes up. So I know my graph goes down here and up here. Do y'all see I'm just putting together things I've already learned about polynomials? Now, why didn't I do that on the previous one? Why did I not do this leading coefficient test? Why did I not? I could have, but why didn't I? Well, this was factored already, right? So I didn't have the leading coefficient easy. It wasn't easy for me to just quickly look at it and go, oh yeah, it goes up, down, left. You know, I didn't have that because it was already factored. I would have had to do an additional step. I could have, but I didn't. Here, because this one was not factored, I real easily can tell the left and right-hand behavior. And back from the X-intercepts, I know whether or not I cross our bounds, right? What do I do at 0? Do I cross our bounds at 0? What's the multiplicity on that factor?
Would that be a bounce?
That's a bounce, right? Because it's 2, that's an even number. So I know that here I'm going to bounce. I bounce here. And then this one, the power on the factor, the multiplicity is 1. That's an odd number. That means I'll cross. So if I were to do a quick sketch of this, I would go up and I would bounce off 0 and I would cross through at 3. Make sense? And then all we want to know is, when is this thing bigger than 0? Right? Which means we want to know when the graph is above the x-axis, which is just over here, right? Everywhere else it's below or touching the x-axis. So my solution here, do I want to include 3? Do I want 3 there or not? If I plug 3 in, what does it give me? Gives me 0, right? Do I want 0? I want strictly greater than 0, right? So I don't want 3. I just want everything to the right of 3. 3 to infinity. So can you see that for these, your ability to, I guess your understanding of polynomial functions is directly related to whether or not this is going to be an easy problem or a hard problem, right? Like, you've got to understand how to graph polynomial functions in order to do these. And if you're good with the polynomials, these become actually pretty quick. I mean, they can be pretty fast problems. Let's do another one. Okay. Well, the first thing we need to recognize is that it's an inequality, right? But I don't have, like the previous ones, these were like greater than 0, and this one was also greater than 0. This one doesn't have 0, right? So first thing I'm gonna do is just move everything to one side. So I'm just gonna move everything over. 3x cubed, I'm gonna add 3x squared to both sides, greater than 0. And now I'm going to just work with this. Now, before I proceed with this, well, yeah, let me go ahead and just keep going. First thing I'll do is solve it as an equation. So I'm going to do that in blue. I'm going to just rewrite this as an equation and solve. Okay. And I realized that the left side is polynomial, so I'm going to factor it. I realize I can pull out a GCF. Pull out a 3x squared, you should be left with x plus 1. And then you set each of these factors equal to 0. So if I set that equal to 0, I'm going to get a solution of x equals 0. And if I set that to 0, I get x equals -1. So I have 2 x-intercepts. If I were to look at this as a graph, I hit the x-axis at 0 and at -1. And I'm treating this like I'm looking at the function f of x equals 3x cubed plus 3x squared. And using the leading coefficient test, this is very much like the previous problem. We have an odd degree and a positive leading coefficient. If you go back again to that table, go back to that table, left side goes down, right side goes up. Okay. I told you about my 2 dogs and one of them we had to put to sleep, right? Did I tell you all that story? Okay, so the other dog just had like major surgery like two days ago, and now he's just like pissed off at everything. Man. He's just mad. Dude, chill out, man. I'm gonna go lock you up. Chill out. It's my wife's dog. All right, left side down, right side up. Is that okay? And then let's see, at -1, I'm going to cross through at -1 because the multiplicity on that factor is odd. And then at 0, I'm going to bounce because the multiplicity there was 2 on that factor. So that's even, so bounce. So if I draw this, I should cross through it at -1, bounce off at 0 and go up. And we're interested in when this thing, again, this is kind of getting boring here because again, they just want to know when it's greater than 0. Okay, so anywhere that it's above the x-axis, right? Which would be in this little region and in that little region right there. I do not want to include -1. I do not want to include 0 because at those 2 values, my graph touches the x-axis, which means it's equal to 0. This inequality says strictly greater than 0. So my answer here will be -1 to 0 union 0 to infinity. Questions?
If it included 0, would we have put the union or we would?
Yeah, I was going to do that right now. I wasn't, even if no one asked me, I was going to do it. So what would happen? What if this problem had been 3x cubed greater than or equal to -3x squared? Well, we would have done the exact same work, okay? And everything would have come out exactly the same. In fact, I'll just copy this. Okay, we would have had this. But the deal here would be that because the inequality has the equal sign on it, right there, I would actually be okay with including the -1 and the 0, right? I would be okay including those. So my solution would look like this. I would include -1, and then I would not have to stop at 0 because I'm going to include 0. It's going to be everything to the right of -1, including 0, and then everything past it. So I would just go to infinity. You see? Now, if you did this, if you wrote this, technically that would not be wrong. It would just kind of demonstrate that you don't quite get that you don't need the 0 there, you know, because you're including it on both of them. So you don't need it there. It's implied, this implies that the 0's in here, right? But those are technically both correct. Does that answer? Yes, Javier? Okay, good. Any other questions? Let's see what the next one has for us. Okay, well, all right. This one's not, this one is factored already, right? You all see that? It's factored, and we have this. So now that we kind of know what we're going to wind up doing here, maybe it's worth it for us to real quickly see if we can figure out the left and right hand behavior. Do y'all remember how to do that if it's factored already? Like if this was a function, f of x equals x minus 1 times x minus 4 times x minus 5. Let me see if I can go back in the notes and see when we did something like this. Here we go. yes. Okay, yeah, here we go. This was on the 7th of March. So here's an example where I gave you a function that was already factored. And I was like, hey, what's great about this is we can find the x-intercepts real easily, just setting each factor equal to 0. And we can tell if it crosses or bounces by looking at the multiplicity. But when it comes to the left and right hand behavior, we just had to analyze kind of what's going on with each factor. So that's just showing you that we did talk about this. So what I mean is this behaves like an x, because it's just x minus 1 to the first power. So it really behaves like an x. This behaves like an x, and this behaves like an x. So if I were to multiply all this crap together, which I don't want to do, I know that what I'm going to wind up getting as the highest power of x is x cubed. So I know that it looks like x cubed. And then as far as a leading coefficient, all of these had 1s in front of them. So it'd be 1, 1, 1. If I multiply all those together, I get a 1. So that tells me right now that I have an odd degree in a positive leading coefficient. And that means the left side goes down and the right side goes up. In the middle, we don't know. So let's see if y'all can, does that make sense? Again, you maybe need to go back and look at the notes for that. Now, in your review, I gave you a problem like that right here, number 2. Number 2 is a perfect example of that situation. It's already factored. You can tell me it's going to cross, bounce, cross. The thing you don't know is the left and right hand behavior, but you can say, oh, this acts like an x cubed, this acts like an x to the 4th, this acts like an x squared. Okay, let's get back to this. All right, so let me see. I'm going to try and do this without writing much of anything else. All right, let's see if you can follow me on this. Here's what the graph of this looks like. I know it hits at 1. I know it hits at 4. And I know it hits at 5. So all I did there was just mentally, I set each of these factors equal to 0, right? So I got 1, 4, and 5. Y'all good with that? Those are x-intercepts. Now, am I bouncing or crossing at each of these?
Crossing.
Cross at all of them, right? Because they all have an odd power. So I'm going to cross everywhere. And I also know the left side goes down, the right side goes up. I know that from this. So that means I'm going to cross through, cross through, cross through, like that. Now, I'm interested in when this thing is less than or equal to 0, which means I want to know when the graph is below the x-axis or touching the x-axis, right? So that would be this region here, including the 1, the 4, the 5, and everything between the 4 and the 5. That's where the graph would be either equal to 0 or below the x-axis. So let me see, that's everything to the left of -1. So here comes my answer, solution. Everything to the left of -1. So negative infinity to negative, sorry, not -1, 1. Include 1 or no? Yes, include 1 bracket. Okay, union, now I want 4 to 5, everything in between, and including both the 4 and the 5. So bracket 4, 5, bracket, done. Let's not lose sight of the fact, of what we're doing here. What we're saying is that for this original problem, right, this original inequality, the question was, what values of x can you plug in that would keep this thing true, to be true? And what we're saying is that if you pick any x here or here, it's going to work. So let me just pick as an example. If I pick 0, right, is 0 a solution to this inequality? It should be. Let's check it. If you plug 0 into this, what happens? 0 into there, you get -1. 0 into that one, -4. 0 in that one, -5. is that less than or equal to 0? Well, 3 negatives multiply together to be negative. So we're going to get negative 20 over here, less than or equal to 0. That's true. And I know that any number to the left of 1 is going to work. Any number between 1 and 4 is not going to work. Any number between 4 and 5 will, and anything past 5 won't. Okay? You'll feel all right? Can I clarify anything? Do you need me to go through something on this? Kind of getting a little bit bored with this 1 and 3 again, right? I already know then left side's down, right side's up. That's like the third or fourth one we've had that's doing this. I don't know why. They need to mix it up a little more, but right? What I don't know is where the X-intercepts, and I also don't know if I bounce across at them. So I'm going to go ahead and turn this into an equation. GCF, right? I can call it X. And then I have a quadratic in there that hopefully factors. Remember that if you have trouble factoring this, you could also use synthetic division, right? Like we learned that as a new way of factoring. It would just kind of suck because you'd have to write out all the different factors of 72 and then try them in the synthetic division. But I think that that's a reasonable factoring problem. I don't think that that's, oh, sorry, this should have been equal 0. 9 and negative 9 and positive 8. X minus 9 plus 8, right? Negative 9 times 8 gives you negative 72, and negative 9 plus 8 gives you negative 1. So I am trusting that as 1414 math STEM students moving on into pre-cal, that all of you can factor that quadratic. I think that one's within reason. All right, what can you tell me? What do you know now? Can anybody tell me if I just start drawing this? Can anyone tell me what I have here?
If you set the negative 9 and the 8 equal to 0, you have your X-intercepts.
Okay, so what are the X-intercepts then?
Positive 9 and negative 8.
There's one more.
Oh, and 0.
0. Okay, so from just looking at that, right? Just visually looking at that, I know that when I set these equal to 0, I'm going to get 0, 9, negative 8. And then am I crossing or bouncing at these?
Cross on all.
Cross on all of them, right? Because I have positive 1 powers on all of those. And I also know the left side goes down, the right side goes up. So it's going to go cross through, cross through, cross through. And we are interested in where this graph is bigger than 0, strictly bigger than 0, right? Which would happen here and here. And we would not want to include those points, right? Do not include negative 8. Do not include 0 because that's where it's equal to 0. So my solution would be not including negative 8 to 0, not including 0. Union, and then not including 9, but everything past 9 forever to infinity. See, when you get to a calculus class, you want to be able to know what the general, like generally when something is positive or negative for a function. And so this is what we're basically doing here is we're saying, hey, is there an easy way to look at a polynomial and figure out when it's positive, when it's above the x-axis, when is it below the x-axis? This is exactly what we're doing here. All right. But we don't want it to take half an hour. All right. Okay, look at this one here. All right, I'm going to move everything over. Let me turn that into an equation. Any ideas on what to do there? Oh, you know what? I do know something that, and when I graph this, I know the left side goes up and the right side goes up. Why do I know that? Even power, positive leading coefficient. Now, I didn't state this earlier. You know, I should, maybe I should have, but I'm referring back. Let's see how far do I have to go back? February. Where is this? Synthetic division. Here we go. Leading coefficient test. 28th of February is when we did this thing. So now that we're like midway through class, let me mention this. On this exam, okay, on this exam that's coming up on Monday, I'm going to allow you to have one reference page to use on the test. Now, what I mean by that is you can get one 8.5 by 11 standard sheet of paper, okay, one of them, and you can write down steps, procedures, anything that you think will help you to get through these problems. Like I would put the leading coefficient test, that table right there, I put that on there, okay? I also gave you steps, right? I gave you like here, how to sketch polynomial functions. I don't mind if you write all this down, okay? Same with rational functions. There was a whole set of steps. What you cannot have are worked out problems. Okay, so you can't just sit there and like work out the review and use that as your reference sheet. Steps, procedures, formulas, quadratic formula, you know, little hints to yourself on how to do things. That's all good. All right. You'll turn that in with your exam. All right. And when you show your camera your pages, you'll have to show that page and then submit it with the test. All right. So I'm only going to say that verbally here in class today. All right. So if somebody is not here and not going to watch this, then they're not going to know about that. All right. So everyone got that? Okay. So back to today. Let's go. Where am I? Okay, so here we go. I looked at this. I said, okay, moved everything over. I'm looking at this thing as a function. It's a polynomial. It has an even power, even degree, and a positive leading coefficient. That means left side goes up, right side goes up. Okay, I know that much. All right, now I need the x-intercept. So how would you go about solving that? Can we factor the left side?
It's a difference of squares, right? So
That is a difference of squares. It factors to be, it's kind of weird, but it's x squared plus 1 times x squared minus 1. Right? Because if I asked you to factor, if I said, hey, everyone, factor x squared minus 1, I think everyone would be comfortable. I hope everyone would be comfortable doing x plus 1, x minus 1. If we had x squared minus 1. But if you have x to the 4th minus 1, it's this same thing, but with squareds here. And you can check it for yourself. FOIL it out, it comes back. It will go back to x to the 4th minus 1. But see, at this stage, we can keep factoring. Now, the x squared plus 1, I'm going to leave alone. I'll talk about it in a minute. This one factors further. So this blue became these two, right? Now this one in yellow, x squared plus 1, I left it as x squared plus 1 because there is no formula to factor x squared plus 1. X squared plus 1 does not factor, right? It doesn't. There's no way to do it unless you bring imaginary numbers in, but we're not doing imaginary numbers. So that's it. That's it. That's the furthest we can go to factor. So what we do now is we set all of these equal to 0. So I know when I set that to 0, I get -1. When I set that to 0, I get +1. I know I'm going to cross here and I'm going to cross here. right? And if I try and set that to 0, if I try to, I get x squared equals -1. And then this has no solution, no real solution. Meaning there's no number that you can square and get -1. That's an imaginary number, which we're not allowed to deal with here in this class. We're not messing with imaginary numbers. Which means you only have 2 x-intercepts. You have an x-intercept at 1, x-intercept at -1. You know, the left side goes up and the right side goes up. And you're going to cross through at each of them. So you're going to cross through here and come down, cross. It almost looks like a parabola. And what were we interested in here? I forgot. We wanted to know when this thing was bigger than 0, right? Strictly bigger than 0, which means that we have to be above the x-axis. That's here and here. So everything to the left of -1, not including -1, everything to the right of 1, not including 1. So how about this? -infinity to -1, union 1 to infinity. How do y'all feel? Okay. Let me see what the next one is. Okay, yeah, we're about to switch gears and go into rational inequalities. So I wanted to mention something. It's off topic, but kind of on topic. This came up with a student in my calculus class, my Cal 2 class yesterday. And if I've mentioned this before, I apologize. I'm going to mention it again. We were working through a problem and we were trying to solve something like this: x cubed equals x squared. All right. Now, it wasn't exactly this problem, but it was similar, something similar to this. And so I was asking the student, I said, okay, how would you go about solving that? Right. And I said, well, we can divide both sides by x squared. And if you do that, you'll get x equals 1. Okay, does that seem reasonable to you? Let's check. Does that answer work? Here is the original equation. We said x is 1. If you plug 1 in here, is it true? 1 cubed is equal to 1 squared, right? That's true, right? So yes, I agree, that works, right? You got x equals 1 as an answer. I agree. But what about x equals 0? Doesn't x equals 0 work as well? Right? It works. If I plug in 0, it works. But somehow you don't have that answer here, right? You missed that answer somehow. How did you miss the answer? You missed the answer because you divided by x squared. And when you divide both sides of an equation by something, you have to promise me it's never 0. It's like an unwritten thing. You don't even realize you're doing it when you're doing it. But when you divide by a variable, let me say again, if you ever divide both sides of an equation by a variable, you're automatically eliminating 0 as being a possibility. So this is the incorrect way to do this, all right? This is wrong, okay? The correct way to do this is this. You bring everything over to one side. So I bring the x squared to the left and write it as an equation like this. Then I factor x squared out, GCF, and then I set each of these equal to 0, and I get 2 answers. And do you see now I have both solutions? So what's the moral of the story? The moral of the story is this: if you're ever working with an equation, you are always free to divide both sides by any number, okay? You could divide both sides by 4. You can divide both sides by -10. You can divide both sides by pi. It doesn't matter if you divide by a number. As long as that number is not 0, you're allowed to divide both sides. But when it comes to dividing both sides by a variable, well, now you're getting into danger zone. It's always better to move everything to one side and then try and factor and do some GCF, all right? So just a warning as you move ahead. Don't ever try and solve an algebraic equation by dividing both sides by the variable. That's dangerous, all right? Okay, so now we move on. Now we are looking at a new type of inequality. Notice the left-hand side is not a polynomial anymore. It's a rational expression, a ratio. It's a rational function, basically, right? It's a rational function. So I'm going to try and do this. Let's see if we can do this. Like, now that we've kind of got our head wrapped a little bit around what we were doing with polynomial inequalities, let's see if we can't just go right into this, treating this like a rational function, okay? If I were to ask you to graph that for me real quick, how quickly could we graph this? Let's see. What's the x-intercept of this function? How do you find the x-intercepts of a rational function?
Would it be -2?
-2, you set the top equal to 0, right? So I already know that at -2, I have an x-intercept, right? Now, there was something else we had on this function. If we set the bottom equal to 0, right? If we set the bottom equal to 0, that gave us what?
Was it the y-intercept?
Not the y-intercept, no.
The vertical asymptote.
Vertical asymptote, vertical asymptote. So at 2, I know this thing has a vertical asymptote like this. I can say that about this function just by looking at it. If I set the top to 0, I get this. If I set the bottom to 0, I get this. Understand? Now, unfortunately, with rational functions, we don't have the whole bounce cross thing, right? We don't have that easy way to draw the rest of it. We had to pick all these test points and everything, right? So that's exactly what I'm going to wind up doing. I'm going to have really no way around this. I'm going to have to just pick a test point here, test point somewhere between here, and some test point here. And remember what we're looking for. We're trying to figure out when this thing, right, when this thing is smaller than 0. So let's test -3. If I plug -3 into that, I get -3 plus 2 over -3 minus 2. And the question is that less than 0? So let's see, we get -1 on top, and on the bottom you get -5. A negative divided by a negative is positive. So is 1/5 less than 0? Is a positive number smaller than 0? No. What does that tell me? That tells me nothing over here works, okay? Nothing to the left of -2 works. Nothing over here. So I'm going to just do it this way. None of this works. Nothing over here works, all right? Now I have to plug in 0. Let me test 0. What happens if I do 0 in here? 0 plus 2 over 0 minus 2. Is that less than 0? Well, you get 2 over -2. Is that less than 0? Well, that's -1. Is that less than 0? Yes. So that means, yes, indeed, everything in here should work. And then we try 3. So if I do 3 plus 2 over 3 minus 2, is that less than 0? Well, that's 5 over 1. That's less than 0. No, that's not true. 5's not smaller than 0, which means that we don't want to include this. So the only values of x that you can plug in to make this thing true are the things between -2 and +2. Do we include -2? Why not?
Because it's not equal to 0.
Because it's not an equal here, right? So we don't want to include -2. Do we include +2? No, but why? There's a reason why we include it. It's not the same reason we don't include -2. Why don't we include 2?
Because it's not an x-intercept.
It's actually a point you are not even allowed to plug in, period. End of story. You can't plug 2 in at all. If you try and plug in 2, you get division by 0, right? 2 into here gives you division by 0. So this 2 is not going in because it's like not in the domain of the function to begin with. This -2 is not going in because of the inequality. It doesn't have the equal underneath. So we're not going to include either one, but it's kind of different reasons why. So my solution here is everything between -2 and 2. And that's it. Not including, no brackets. So I guess if I were to try and kind of re-illustrate what I just said, if you were to take this problem and change it into where this does have an equal sign underneath it, okay, our answer would only change in this sense. You would include the -2. You would still not include the 2 though. You're not allowed to include the 2 because you can't plug 2 into this. You'll see the difference. Questions? Michelle? You understand? Okay. The left side of this is a rational expression. Let's see how quickly I can get through this. Well, why don't you try it? I'm going to give you like 2 minutes. Right now, just by looking at the left side of this, you should be able to quickly identify any x-intercepts and any vertical asymptotes. Once you do that, pick a few test points and then plug them in and see if it's true or false. I'll give you 5 minutes. How about that? You let me know in the poll if you finish this, let me know. Or when you finish this, let me know.
Would we have 4 test points or 3 test points?
How many x-intercepts do you have?
2.
How many verticals do you have?
I have 1 vertical asymptote.
So the total of those two together is 3,
Okay, so just 3.
which means you'll have 4 test points.
Okay, perfect.
Yep. So it's been 5 minutes, but we only have 3 students done. So I'm going to go another minute or so. Okay, I'm going to go ahead and work through it pretty quickly here. I know only 5 or 6 of you were finished, but just by looking at this, I can just look at the numerator and tell that I have 2 x-intercepts, one at 7 and one at -5. That's just setting the 2 factors equal to 0. If I set the denominator equal to 0, I get 0. So I have a vertical asymptote that goes through the y-axis. And so I've got to pick some test points. I'll pick like -6, -1, 1, and maybe 8. And then I have to plug those in here and see if I get either, positive or negative out. So if I plug in -6, I get -6 minus 7, and I get -6 plus 5, and then over -6. And I'm checking to see if it's bigger than or equal to 0. So I get a negative here times, and then this is a -1, so another negative, and then over -6, which is negative. And 2 negatives on top multiply to be positive, and on the bottom negative. And I know that a positive over a negative is negative, and a negative is not bigger than 0. So that would tell me that everything to the left of -5 doesn't work. And then if I test -1, I believe -1 should work. +1 will not work. And everything to the right of 7 will work. So I'm not showing those. Is that okay? I'm not actually plugging in -1, 1, and 8, but you should get like true, false, true for those 3. Now, the answer. Questions or no? So far? Do I want to include -5? I forgot to put 0 here. Do I want to include -5? Yes, because it has an equal underneath, right? So I do want -5 in here. And I want to go all the way from -5 until I get to 0, but 0 is where I have a vertical asymptote. So I cannot include 0. And then I union that. Now I have to go everything to the right of 7. Do I include 7? Yes, because it's actually an x-intercept. So I want to include 7 and I want to go forever. There we go. You understand? I think there's 2 more. All right. I'm going to work this one quickly. All right. If I set the top equal to 0, I get 5. So I know 5 is an x-intercept. If I set the bottom to 0, I've got to look at that as a difference of squares, x plus 4, x minus 4. I actually have 2 vertical asymptotes, one at +4, one at -4. And that means I'm going to have 4 test points. Something over to the left of -4, like -5. Something between -4 and +4. So I'm going to pick 0. This one's going to suck. I've got to pick something between 4 and 5, like 4.5. And then something to the right of 5, so something like 6. And I've got to test each of these. All right, I've got to figure out what's happening. So let's see, what happens at -5? -5 minus 5 squared over, on the bottom, I'm going to plug the -5 into the factored version. So I'm going to say -5 plus 4, and then -5 minus 4. What I'm checking to see is if this is bigger than or equal to 0. The numerator is -10 squared. That's 100. That's a positive number. Over -5 plus 4 is negative. And then -5 minus 4 is -9. That's negative. Is that bigger or equal to 0? Well, let's see. Positive over 2 negatives multiplied to be positive. And 2 positives divided is positive. And a positive number is bigger than 0 or equal to 0. So that's true. Which means I want everything to the left here. Y'all kind of catching on to how this is working? X-intercepts, verticals, test points, plug them in, see what happens. Now, if you plug in 0, it is not going to work. Okay. And here's something interesting happens. At 4.5, it is going to work. Okay. At 4.5, it is going to work. And at 6, it's also going to work at both of them. So it's going to work here and here. I'm not showing it, but they both work. So do I want to include 5 or not? Do I want to include 5 or not? Look at my inequality. It has the equal there, doesn't it? So I do want to include 5, and 5 is actually, it's not a vertical asymptote. So I do want that 5 included. And that makes a difference because now if I'm going to write my answer, all I need is everything to the left of -4. So -infinity to -4, include -4 or not? No, can't, right? It's a vertical asymptote. You can't plug -4 into this, right? You'll get division by 0. So I don't include -4. I don't include anything here, but everything from 4 on, right? Everything to the right of 4, including 5, and everything keep going to the right. So I'm going to go union 4 to infinity. Why didn't I include 4? Again, we have a vertical asymptote there, right? So I can't actually technically plug 4 in, but I can plug in everything to the right, including the 5, and on forever. Are we good? One more, and we're done. This one's tricky, okay? This one's tricky. We'll star next to this one. Please do not let me get you on the test with this one. This one is a little challenging. Do y'all see the big difference between this problem and the ones we've done leading up to this one? Here's the one we did before. Here's one we did before. Here's one we did before. So the 3 that we did before, compare those to this one. Do y'all see the big difference? What is it? You got a 3 here, not a 0. Okay, that changes everything. That changes everything because when we have it less than or equal to 0, then all we're doing is we're looking at the left side as the function, and then we're just trying to figure out where it's above and below the x-axis. This is trying to figure out where this graph is below or equal to 3, which is not the x-axis anymore, right? So the only way to work around this easily is to do this. You've got to move everything to one side of the equation, all right? Please do not let me get you with this, okay? It wouldn't be something I'm trying to do. I'm going to subtract 3 on both sides, okay? Now, before I proceed, I have to put these two things on the left side together, which means I need a common denominator, which means I'm going to introduce, this is like a 3/1. So what I'm going to do is I'm going to take the 4x minus 5 over x plus 3 minus 3/1, but I'm going to multiply the top by x plus 3 and the bottom by x plus 3. And then I still have, I'll go ahead and make it the equation now. Okay, I'm going to start treating it like an equation here. Or you know what? I'll leave it as an inequality. Let's just leave it. Okay. So we're now, we can put these two together. Now, when I put those two together, I'll get the 4x minus 5. Now, when I distribute through here, I get 3x plus 9, right? But we are subtracting this fraction, which means we need to subtract the 3x and subtract the 9. Look, they both got minuses. This minus distributes to both of those. And that's all over the common denominator, which is x plus 3 less than 0. Let's clean up the numerator. 4x take away 3x is x. -5 take away 9 is -14 over x plus 3 less than or equal to 0. Now you can play the game. Now you can do what you need to do because now it's less than or equal to 0. Does that make sense, y'all? I mean, that's a subtle little thing, but if you miss that step, it's over, right? So I'm going to go ahead now. I know that I have an x-intercept at 14. And I know I have a vertical asymptote at -3. Set the top to 0, you get 14. Set the bottom to 0, you get -3. I picked some test points. I'm only going to have 3 of them. -4. 0 is a good one. I don't know, 20. Let's go with. You test those points. If you try and test -4, you're going to get a negative on top and a negative on the bottom. And a negative divided by negative is positive, and a positive is not bigger than 0. Or sorry, is not less than or equal to 0. So this is not going to work. If you plug in 0, you will get a negative or a positive. That will work. And if you plug in 20, it won't work. So my solution will be everything between 3 and 14. Oh, sorry, -3 and 14. Do I include -3? Can't, right? It's a vertical asymptote, so nope. Do I include 14? Yes, because it was less than or equal to. What the hell? Oh man. All right, so please, just be careful on the test. Make sure that you've got 0 on this side. If you don't, bring that number over, common denominator, then you can play the game, all right? All right, do you feel like I've given you enough of these that you're going to be able to practice your homework, all right? But Is there anything else that you want to see, or do you feel like you're ready for that? Or feel like you'll be ready for that? Yeah. Okay, here's what I'm gonna do. In the chat, I'm going to send out the solutions to, let me see, hold on. Trying to remember where I put it. Okay, let me do this. Okay, I just sent that in the chat. So what I sent is a set of solutions for the review questions that I gave you last class. Now, I do need to tell you something about this. Let me show you the review questions from last class. Here is the review questions from last class. It started out with a quadratic function and it asked you to graph it. So sketches quadratic, and then polynomial, 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 rational, rational, and then inequalities. That's what the test is going to cover. I've had someone just asked in the chat what the test is going to cover. Section wise, we're covering basically quadratic functions, right, in their graphs. Quadratic inequalities is kind of included because it's polynomial inequalities are basically the same thing. Polynomial functions, rational functions, right? That's, and then the inequalities that we just covered today. Does that answer the question? I mean, synthetic division, long division, like that's all, synthetic is built in to the polynomials. You got to be able to do synthetic for some of the polynomials. So that's all kind of built into the problems. So let me tell you, on the review, notice it starts with number 1 is 2x squared plus 5x minus 11, right? And I ask you to sketch that. On the solutions I just sent you, number 1 is not that question. Okay. It's actually number 3. So the reason is I gave you an old review, and on that old review, there were a few questions that I asked the students that you guys have already done. So you'll be able to match up the answers. You can see the questions right here. Number 3 on the solutions is number 1 on your review. Number 4 on the solutions is number 2 on your review. And you can kind of work through this. You can see on one of these, I had to do synthetic division. This one I had to do synthetic division. Here was a rational function, sketching. Are there any questions on that? Did y'all get that in the chat? Did it come through? Yeah. Okay.
I didn't receive it in the chat.
You didn't get it?
No.
I'll send it as an email. I don't know why the chat works that way. Sometimes certain people don't get it. Wait, this is exam 2? This is exam 2? Oh. Okay, here we go. All right, I just sent it in the oops. All right, it just was sent as an email. All right, so we have 20 minutes. You're free to go. You're free to stay, ask questions. If there's anything you want me to do, I'd be happy to do whatever. It's your time.
I have a question about number 2.
Number 2 here.
Yes, sir.
Okay.
How would you how would you start that one off?
Okay, well, if we're gonna follow, it's a polynomial function, right? Let me bring up the solutions and see if we can follow through on the solutions, how I did it. Where is it? Oh, come on, I just sent it. Did I close it? There we go. Okay, so the way that I would do this, I would start by, the leading coefficient test is the first step to sketch a polynomial function. So I would look at the first factor, x minus 2. I would see that it's cubed, which means that if I were to multiply all that out, the biggest power of x I would get would be an x cubed. And then here, if I multiply this out, because it's to the 4th, I would get an x to the 4th as the biggest power of x here. And if I multiply this out, I would get an x squared. Now, I'm not actually going to multiply those out. I'm just thinking like, okay, the highest power of x I get here is x cubed. Highest power of x I get here is x to the 4th. Highest power of x I get here is x squared. If I were to multiply those together, I would get an x to the 9th power. That means the degree is odd. And then the leading coefficient is a 1 because all of these x's have 1s in front of them. So because the degree is 9 and the leading coefficient is 1, I go to that table. I know my left side goes down, my right side goes up. Is that okay, Javier? Okay, then what I would do is find the x-intercepts. To do that, I set the function equal to 0 and I factor it. Well, it's already factored, so that's great. I don't have to do that step. I just set each of the factors equal to 0 and then look at the powers for the multiplicity. And I've got an odd, that means cross. I've got an even, that means bounce. I've got an even, that means bounce. So then I go to my picture. And to do this, I'll do it over here on the side. Are you not going to work for me? It's not going to work for me. Okay, fine. Give me a moment. I need to restart my computer soon. It's starting to give me indications of it needs a fresh start. Okay, so once I would be here, I would go to plot my x-intercepts at 2 and at -3 and +7. And I know that my left side goes down and my right side goes up. And then at -3, I'm going to bounce. So I bounce, I bounce off the x-axis. At 2, I cross. So I cross through. And then at 7, I'm going to bounce. So I bounce off and go back up. Okay, that's how I do that one.
Thank you so much, sir.
Yep.
You have a good one.
You as well. Anybody else want me to talk about something?
I do. I have a question and it's for that same problem.
Mhm.
So what would we do in an instance where there's not always a 1 in front of the x to find like the...
Yeah, so let's say that there would have been, let's say, a 2 right in front of that x.
Mhm.
Okay. All right, so you're basically going to take a 2x and cube it, right?
Yes.
Means you would cube the 2 and the x, which would really act like an 8x cubed. Make sense?
Mhm. Yes.
Okay, so let's say that's all we had. So this would become an 8x cubed. Then we multiply all those together. This would act like an 8, right?
Mhm.
And then that actually wouldn't change anything because the degree is still 9. The leading coefficient here is positive. So you would have the same thing happen. Now, what if it was a -2? Well, you're going to cube -2. That's -8. And then you're going to have a negative leading coefficient, which means it would go like this instead. Now, my intention is not to give you anything like that because I never did that to you. I'm going to keep it nice and clean, but that's what would happen.
Okay,
Okay.
thank you.
Yep.
Could you clarify could you clarify what homeworks we're doing? Like, are we still doing 5.3 and 5.4 and 5.5?
No, the only homeworks that are due on the online system is 5.5.
Okay, because
Okay.
it's showing up on Canvas if 5.3 and 5.4 were due yesterday.
That's
So
right.
I got
But I
confused.
also told you all at the beginning of class last time, right?
Mhm.
Where's my notes? Right, last class, very beginning. Homework will be assigned in class date, and I told you all just to look at the review. That's what I asked you to do
Okay.
for homework. Is this? So the online system, I actually removed those, unassigned those homework sets this morning, I believe.
Okay, thank you. So we
So I
just do
understand, I
5.5?
understand the confusion, but
Yeah, that's what I was going to ask about too.
yeah.
I was
So
looking
the only
for-
thing that you have to do online right now is the homework from today, which is the 5.5.
Mhm.
And where is that? Yeah. So 5.5 homework will be done online using the same system we've been using. And the problems I did in class today were basically taken out of that homework assignment. So your problem should look very similar to what I did. All right.
Okay. Yeah, that's what I was going to
Thank
ask, because I
you.
know I was doing the questions, and then I started to do the on the Canvas homework assignments, but then I didn't see them this
Yeah.
morning.
Yeah.
So perfect. Appreciate it.
Yep. Just work on that review.
Yes, sir. Have a good one.
You as well.
I have another question. So
Yes.
you know how you said that some of the notes are like in a file that you composed for us?
Yes.
I can't find that file, or unless I'm like looking for it in the wrong section.
I believe I sent an email. Oh, let me actually update today's notes while you've got me thinking about it. So let's see. I sent an email. Let me see if I can find when it was. Zoom notes link. Here we go. Let me see. So I don't know, maybe check your Canvas email February 7th.
Okay. Oh yeah, it's a Zoom notes link, right?
Yeah, click on it, make sure it opens.
Oh yeah. Yeah, I'm sorry. I was looking it over in like where it says like courses, and that's where I was looking at. And that's why I couldn't find it. But now I do have it.
Okay, very good.
Okay, thank you so much. Have a good one.
You as well.